You have exactly 4 billion addresses to run the entire internet. Every phone, laptop, smart fridge, and IoT sensor competing for a slice of 2 to the 32nd power. And we have been out of IPv4 addresses for years. Arine ran out in 2015, RIPE in 2019, LACNIC in 2020. The regional internet registries are empty. So how does the internet keep growing? The answer is IPv6. By the end of this video, you will be able to read, write, and configure IPv6 addresses on the CCNA exam. That IPv4 gives you 2 to the 32nd, about 4.3 billion addresses. IPv6 gives you 2 to the 128th, 340 undecillion. IPv6 addresses outnumber grains of sand on Earth by up to 3.4 quintillion. We will never run out. Before we can read IPv6 addresses, we need hexadecimal. Hexadecimal uses 16 symbols, 0 through 9, then A through F. A single hex digit represents exactly 4 bits, a nibble. So 1110, 11 in binary is F. 1110 is A. Converting binary to hex is 3 steps. Take 1101, 101, 0010, 101111. Step 1. Split into 4-bit groups. Step 2. Convert each to decimal. 13, 11, 2, 15. Step 3. Map to hex. DB2F. The answer is DB2F. Reverse the steps to go the other direction. Practice until it is automatic. Now let us look at the IPv6 address itself. An IPv6 address is 128 bits, divided into 8 groups of 16 bits each, called hextets, separated by colons. A full address looks like this: 2001 0db8 5917-abd 6562 117 ea-92d 59bd. That is 32 hex digits, long but manageable, and we can make it shorter with 2 abbreviation rules. Rule 1, remove leading zeros from any hextet. 0db8 becomes db8, becomes 0. Trailing zeros stay. Rule 2, replace consecutive all 0 hextets with a double colon, but only once per address. If you have multiple runs of zeros, pick the longest one, or the leftmost one if they tie. RFC 5952 gives us the official style guide. Always remove leading zeros. Always use the double colon to abbreviate as much as possible. Never use it for a single 0 hextet. Write hex letters in lowercase. The IPv6 header is 40 bytes, fixed size unlike IPv4. It has 8 fields: version, traffic class, flow label, payload length, next header, hop limit, source address, and destination address. The next header field works like the IPv4 protocol field. 6 means TCP, 17 means UDP, 58 means ICMPv6. IPv6 uses /64 prefix lengths almost exclusively. The first 64 bits are the network portion. The last 64 bits are the host portion. To find the prefix of an address, like 2001-db8-1 to A SIR64, simply zero out the last 4 hextets. 2001 db8 1 2/64. Now let us configure a router. The very first command you need is IPv6 unicast routing in global configuration mode. Without it, the router will not forward IPv6 packets. This is the #1 thing people forget. IPv4 routing is on by default. IPv6 is not. To assign an address manually, use IPv6 address followed by the address and prefix length with slash notation. No dotted decimal subnet masks. And here is an important difference from IPv4. If you configure multiple IPv6 addresses on the same interface, they all stay. They do not overwrite each other. In IPv4, the last address wins. In IPv6, every address you add is cumulative. For automatic address generation, there is modified EUI64. This takes the interface MAC address and turns it into a 64-bit host identifier in 3 steps. Step 1. Split the MAC in half. Step 2. Insert FFE in the middle. Step 3. Invert the 7th bit. Take MAC address 0060.2f62.b803. Split it 0060.2f and 62.b803. Insert FFE 0060.2FFF FE62 Straj F Skjøterpillet2. Invert the 7th bit, the 3rd bit of the 2nd hex digit. 0 becomes 2. The result is 02602FFF FE62/803. Combine with the prefix and you have a complete address. This 3-step process is a guaranteed exam topic. Now for the 5 IPv6 address types. First, global unicast. That 16-bit subnet space means 65,536 subnets. The 2001 DB8/32 range is reserved for documentation. Second, unique local addresses, the IPv6 equivalent of private IPv4 addresses. They begin with FD, the FD00/8 range. After the FD prefix comes a 40-bit globally unique random ID. Then, the same 16-bit subnet and 64-bit host structure. They work inside your network, but are dropped by ISPs. Think of them as the IPv6 version of 10.0.0.0/8, 172.16.0.0/16. Third, link local addresses. Every IPv6 interface must have one. They use FES80/64 and are automatically generated using modified EUI64. Link local means the address only works on the directly connected segment. This is required in IPv6. Not optional. Fourth, multicast. Here is where IPv6 makes a bold choice. There is no broadcast. No more flooding a segment with a packet addressed to every device. IPv6 uses multicast exclusively. The range is FF00/8. The last digit of the first hextet determines the scope. FF01 is interface local. FF02 is link local. FF05 is site local. FF08 is organization local. FF0E is global. Essential link local multicast addresses. FF02/1 is all nodes. FF02/2 is all routers. FF02/5 is all OSPF routers. That are simply 6 is all OSPF DRs and BDRs. Clash9 is all OIP routers. That F-A is all EIGRP routers. These are the IPv6 equivalents of the 224.0.0.x addresses you know from IPv4. Fifth, anycast. One-to-one of multiple. The same address is configured on multiple hosts, and routers deliver the packet to whichever host is closest. No reserved anycast range. It is a unicast address used in a special way. CDNs like Cloudflare use anycast so users connect to the nearest server automatically. 2 more reserved addresses worth knowing. The unspecified address is all zeros, written as the IPv6 equivalent of 0.0.0. It is used as a source address when a device does not yet know its own address. and in default routes as /0. The loopback address is /word, equivalent to 127.0.0 to 1, used to test the local networking stack. Let us bring this together. Google reports nearly 45% of its users accessing over IPv6, up from about 1% a decade ago. The adoption curve is real. Well, you now know the full picture. IPv4 exhaustion is a present problem. You can convert binary and hexadecimal. You can read and abbreviate IPv6 addresses. You can configure them on Cisco routers with IPv6 unicast routing and IPv6 address. You can generate host identifiers with modified EUI64 using the 3-step process. And you can identify all 5 address types: global unicast, unique local, link local, multicast, and anycast, along with their ranges and scopes. The CCNA exam will test every one of these concepts, but more importantly, the networks you will work on are already using them. IPv6 is not coming. It is here, and you are ready for it.